Now that you know how to write an inverse equation, we're going to take a look at those equations along with their graphs and their tables and start to find some similarities and differences. Before we get to that part though, would you please quickly go through and do this warm-up, just finding the inverse equation for it. Go ahead and pause it. So remember, to find the inverse equation, we have to write out our operations. The first thing that I would do is add 2. The next thing I'd do is square that. Next, multiply by 3, and lastly, subtract 6. So therefore, when I write my inverse equation, the first thing that we're going to do is we're going to first add 6, then we have to divide by 3, then we're going to have to square root, and lastly, we're going to subtract 2. Now, I purposely didn't write this equation. We'll come back to this, so put this in a safe place as we go through the rest of the video, and then we're going to check those equations that you created. So, first thing that we're going to look at is, here we have a regular equation. Y equals 0.5x plus 3. Feel free to rewrite this as y equals 1/2 x plus 3. It'll help when we work on our equation. So if I need to graph the inverse of this, what might make sense is just to find the inverse equation. So therefore, if I want to find my inverse equation, I look at my operations. The first thing I'm doing is multiplying by 1/2. The next thing I'm doing is adding 3. So therefore, when I do my inverse equation, since it's just y, we can write y inverse. It's kind of odd, but you can just write it as y inverse. And the first thing I'm going to do to x is subtract 3. And then multiplying by 1/2 is, the inverse of that is dividing by 1/2, and dividing by 1/2 is the same thing as multiplying by 2. Okay, so again, in reverse order. So there's my inverse equation for this. So if I wanted to graph this, I could make a table. And I can start plugging in values for x. I can plug in 0 for x. When I plug in 0, I get -6. I can plug in 1 and get -4. Plug in 2 and I get -2. Plug in 3, I get 0, and I'm going to do one more. Plug in 4 and I get 2. And I could keep going. I could put in negative numbers as well for x. So I'm going to plot those. So I plotted those points, and now I can connect them with a line, and we get that picture. Now, one of the things that I could also do is I could have pulled out some of the coordinate points from the original one. So what I'm going to do is I'm just going to pull out a few of those points from the original graph, y equals 1/2 x plus 3, just so we can take a look at the tables, because we're going to compare equations. Now we have the graphs, and then also we're going to look at the table. So I'm just going to go ahead and write that table out, so just a moment. So all I did was pull the points off of the graph based on where the points were. So we're going to move on. We're going to do another one. We're going to again look at the equations. We're going to look at the graph, and then we're going to look at the tables. So in the next one, we have this nice quadratic, which should look very similar to our warm-up did. But what I want you to do is I want you to go back, and I want you to take a look at, what do you notice about the tables in the first one? So what do you notice about the table of the original function and the table of the inverse? Take a look at the x and y values. Hopefully you noticed the x's and y's flip-flop. Now I don't have this point. 0, 3, and its inverse became 3, 0. 2, 4, and the inverse became 4, 2. So what I want you to do with this function is list out your points. I'm going to add one more point that's on here. So I'm going to go ahead and add this point right here, just to give you that nice parabola shape, so we have 5 points to look at. And then I want you to make the table for the inverse and then graph it without even doing the equation. So pause the video, please. On your paper, list out the table, and then maybe sketch the graph if need be. So all I did was make the table for the original function. So this is for y. Now I'm going to take it and I'm going to interchange those x and y values so I can graph my inverse. So now I wrote my points, just flip-flop the x and y. Be super careful when you do that, and then go ahead and graph them. Make sure you always go with your x and your y. So now I should have those 5 points, knowing that this was my vertex here. So this point right here is like that vertex part of it, so it's kind of that important point. So keeping that in mind when you go ahead and graph this point, look at what does it look like, because that was the point here. That was kind of that really important point. See what happens when you graph the inverse. So that important point, -2, -6, is now the point over here, -6, -2. And what you should see is connecting the dots. That was that lowest point. That was like the vertex. Now it looks like, hopefully, it looks like it's a sideways parabola. So that's part of what we're looking at now is how do we make these inverses. So I took my table, I flipped my table, and then I graphed it. So now what I want you to do is I want you to compare both of these graphs with each other. So we know how to take the tables and interchange the x's and y's. But what else graphically do you notice about the original function and its inverse? So again, the original function and its inverse. Same thing over here, the original function and its inverse. It's a reflection. They reflect over each other. Now, where is that symmetry? Where is that axis of symmetry? That's the next part that's important to realize. So I'm going to go back to this first graph, and we have an axis of symmetry. So they both share here, but all of these points reflect over the line. What is that equation? Y equals x. Oops, that's an x. Same thing in this one. These reflect over the line, y equals x. Because think about it, we switched those x and y values. The x values became the y's and the y values became the x's. So therefore, they reflect over that line y equals x. And the other big thing that I'm hoping that you see is this point right here and this point right here are both on the original function and its inverse and on the line y equals x. Because this point right here looks like it's at the point right around -1, -1. And this point down here looks like it's about at the value -3, -3. So the x's and y's are equal, hence the reason they're on the line y equals x. So you can look at those pieces too. When you have the same x and y value, they will land, right on the line y equals x. Now, we did this equation for our warm-up, and you were able to write the inverse equation for it. We're going to take a look at what happens in our calculator too, so that you can see that as well. But the thing is both of these equations, we could write the inverse of them. But what happens when you get one like this? There's two x's. How do you write an inverse equation when there's two x's? If I look at what each of my operations are, okay, first thing I do is I multiply by 1/6, or maybe I cube it, or I multiply by -13/6. Like, what's actually happening first? When there's more than one x value, that's not possible. So we can't use that idea when we're trying to write the inverse for those. So for this one, it might make sense just to look at the table and graph it. So I'm going to just quickly do this so you can see it. You guys don't have to do this. But I want you to see what the inverse of this looks like. Sometimes the hard part about this is after you've put the dots in, like how do you connect the dots? So just keeping track of going in order with connecting the dots. So therefore, that's what the inverse looks like. And again, you should be able to see it slightly at least when you look at that line of reflection of y equals x. Seeing that each of the points reflect over it. So I can just pick random points that are on here and just double check my reflection. So therefore, I had this point here, so it looks like that should be that point there. So those are kind of like those key like mins and maxes and stuff. So they should cross here, both the graphs should cross there, and both the graphs should cross there. So just looking at some of those pieces. This line's going to infinity this way, therefore this line's going to infinity that way. So just double checking to make sure you have what it is. It's much easier to just reflect the points, which is what I did, than to try to reflect the whole thing over the line y equals x. So I just put each of those points on there, interchanging the x and y, versus trying to literally reflect the whole image. You might be able to reflect points, but just make sure that you can get the graph correct. So again, this is just finding the inverse from an equation without having to find the inverse equation. So we've got that line of symmetry. We know what to do with our x and y tables, and then we know how to interchange or how to rewrite our equation. So the next piece is, and this is hopefully where we're going to catch some of those mistakes that you're going to make, you are going to find the inverse equation for this function. So please go ahead and pause this and find the inverse equation. So what we have, when I write out my operations, the first thing that I'm going to do is I'm going to divide by 2. The next thing I'm going to do is square it. Therefore, when I do my inverse, the first thing I'm going to do to x is square root it. The next thing I'm going to do is multiply by 2. Questions? Okay. So now what we're going to do is we're going to put this into our graphing calculator. So we're going to save the time instead of graphing these by hand. We're going to check this with our graphing calculator because there's something wrong with this. This is not right. So when we go to our calculator, I do want all of you to do this with me. And if you need to rewind or pause along the way, please feel free to do that. So what we're going to do into our y equals, we are going to put the original function that we had. So parenthesis, x divided by 2, close that parenthesis, and that whole thing is squared. So when I graph that, oh, we've got a weird graph. So let's do zoom 6, give ourselves a nice square graph. Okay, so now I have that nice function. So now I should be able to take each of those points and I could reflect them over the line y equals x or interchange my x and y. Or let's just check our equation. So when I go into my y equals, I now put in 2 times the square root of x. Oops, let's try that again. 2 times the square root of x. And we graph that, and we get that. Now I'm hoping that some of you are realizing that you're catching that there's a mistake. This should be reflecting over the line y equals x. I should be able to draw that line in there and have that y equals x line in there. So let's see. So now I can draw that line of y equals x in, maybe. Y equals x. Sorry, not really a line, but you kind of get the idea of it. So everything should reflect over it. So you can see that this part here, let's try that again. So this part here is this part here. This whole part here continues there, right? But what about this part right here? Where does that go? Well, if I reflect this, it should be somewhere in here. Somewhere. Not perfect by any means. So how do I figure out what I'm missing to make that happen? So our calculator has a fantastic feature. The feature that our calculator has is the following. We can physically let our calculator draw the inverse for us, and it'll tell us what part it's missing. So in order to do that, what we need to do is we need to go to this draw feature. So you're going to hit second and program. That's the draw feature. And then if you notice, number 8 is draw inverse. So if I click 8, it is going to draw the inverse. Now I have to tell it what it's going to draw the inverse of. This is a little bit, finicky to get there, but once you get it down, it's not too bad. It's under vars, V-A-R-S, and it's y-vars, so it's y variables. So arrow over to y-vars, and we're going to graph a function. The function we're going to graph the inverse of is y1, because that's where I put it, was in y1. If you put yours in y5, then you're going to draw the inverse of y5, and you'll type a 5. But mine is just under my first one, and then I hit enter. And what it's going to do is it's going to graph the inverse. And that's the part I was missing, and then it's going to go over the top of the part that I was right on. So now I have to figure out what am I missing in that inverse. And the part that you're missing in your inverse is when you square root the problem, there is that positive and negative that's in there. So it's the positive and negative of the square root, and then that's going to be multiplied still by 2. So what I'm going to have to do is, this isn't completely right, my y inverse is the following. So when I first undo the square by square rooting, it's the positive and negative square root of x. And then that is going to multiply by 2. Now I could put that in the front, times 2 in the front, perfectly fine as well. But I have to have that positive and negative that's in there. In your calculator, the only way you can do that is to have 2 functions. So what I'm going to do is I'm going to clear this inverse. We know what it should look like. So I'm going to go back under program, or draw. So second, program, clear draw, number 1. So I'm going to clear that inverse out of there, and now it'll just graph both of them. Okay, so now I have to tell it we need that bottom part. So therefore, down here, I also need that negative. There is no plus and minus sign, unfortunately, so we just have to write both of them out. And again, you could have put times the negative at the end or times 2 at the end. It doesn't matter. But now when you graph it, you get the part that was missing. So the nice thing about your calculator is it will catch those mistakes for you as you make them. So when you look at your original function, it's a function, right? Passes a vertical line test. How about its inverse? Is its inverse a function? No, it fails the vertical line test right here. So just because we graph a function doesn't mean its inverse is a function. We can find the inverse. It's just an inverse, not an inverse function. So when we go back to some of these original ones here, the original one, this is a function. Its inverse is a function. For this one, my original is a function. Its inverse is not a function. And I could have started with this one, which is not a function. Its inverse would be a function. So there's no definitive if it's a function or if it's not a function. Now you can look at some characteristics, and we'll talk about that later on as to determine whether the inverse will be a function or not. But just because one is a function doesn't mean the other one is. Okay, so back to our warm-up. So I purposely did not write the equation for this because I wanted you guys to realize that at this step right here, we square rooted. And what we end up having is we know this original is a parabola. And if I just did the square root, I just get the square root function. But because my original is a parabola, the inverse is also going to be that sideways parabola. It's going to end up not being a function. So when we write our inverse equation for this, the first thing I do is I add 6, and then I divide that by 3, and I square root. As soon as you square root, it's the positive and negative. And then lastly, we subtract 2. So that's your inverse for the original. So for parabolas, you have to be super careful and make sure that your inverse is actually an inverse of what it is. And you can check it with the function in your calculator. It will not tell you what the equation is, but it will graph it for you so you'll know if something's right or wrong. Okay, so lastly, I'm going to have you look at equation writing. Okay, so this was the very first one that we started working with graphing. And we hopefully realized that with that function, our tables, we noticed that the x's and y's switched. The x's become the y's become the x's from our original graph to our inverse. That holds true in the equation as well. If I want the inverse, my x's become my y's, and my y's become my x's. Switch them. And I'm going to make this a half again. I just have to switch my x and y. Now, I want an equation, so I need to get it into y equals form. So now solve for y. Subtract 3 on both sides. So x minus 3 equals 1/2 y. And then I'm multiplying by a half. What does multiplying by a half? Multiplying by the reciprocal 2. So I'm going to multiply both sides by 2. Both sides, whole sides. Goes away. So you get y equals 2 times the quantity of x minus 3, which is exactly what we got over here. So it's another way to write the inverse of an equation is to interchange x and y and solve. So you can write out your operations and then rewrite it this way. The nice thing about this is it helps find inverses of equations that maybe we couldn't have done otherwise. Okay, and that's going to be one of the focuses for the end of the chapter specifically, is how do I undo those operations? Because some of them we don't have ways to undo them. So I want you to pause the video, and I want you to find the inverse function for each of these 4 by just interchanging your x and y and then solving. I'll put the answers up here for you so you can check them, but at this point, pause the video, and then find the inverse equation for each of these. This is the last thing we're going to do for this lesson. Okay, so here are the solutions for all 4 of those. Sorry, they're kind of messy. Double check those really quickly. I do need to add a little caveat on for B, just because it is an odd one of all of them. So once you're good with those, unpause it. So with B, the original graph is a square root function. So that original one's a square root. But the inverse, if we graph the inverse function, it's a parabola. ignoring this part right now. This is a parabola. The vertex at +3, +2. The problem is this has too much. It should only be half of it. So we have to restrict that parabola down based off of our domain. And here's how you do it. It's a pretty quick thing, but you have to take it into consideration. So for the original problem, this starts at the point 2, 3. Okay, so it's a square root function, shifted 2 to the right and 3 up. So what that means is my x values here are 2, my y values are 3, so my domain would be x is greater than or equal to 2. X keeps going to the right. And my range is y is greater than or equal to 3. That's going above. So therefore, in my inverse function, what do we know happens to x and y? My x's become my y's become my x's. So therefore, my domain and range for my inverse function, my domain is what my range was. So my domain now is x is greater than or equal to 3. My range, y, is greater than or equal to 2. Therefore, I need to bring in the restriction of x has to be greater than or equal to 3 because that's what my domain is. So what that means is my function is just from here up. So that's the inverse. So you have to be super careful with square roots and squares. And that's what I have here, which we'll start with our warm-up for the next lesson. For each of these, because these are the two that have the restrictions or have to add in the stuff, the square and the square root. Nice job for today.